Hello friends, welcome back to the channel Learn with Art. Now in this video here we will see how to design PDA for a given language. Okay, so here we have language L is equal to 0 raised to n 1 raised to n where the value of n is equal to or greater than 1. Before going to learn actually how we can design PDA, if you are new to the channel and if you like my videos, then please do subscribe and press the bell icon button for the notification of my latest videos. Without wasting much of the time, we will start with the example. So here first we will list out all the strings that are coming under the language 0 raised to n 1 raised to n. So smallest string will be 0 1, then next smallest string will be 0 0 1 1, then next smallest will be 0 0 1 1, and this will go on repeating. Okay, so for designing purpose, we will first consider here one of the string, that is 0 0 1 1, for actual execution of how means this string should be processed from the given PDA and how we can design the PDA for the given language. Okay, so suppose consider this string is present on input tape and we have stack here. In stack we have top as Z0, means if we have Z0 in stack, then we have our stack as empty stack. Okay, or we are considering stack as empty stack. Okay, so for designing of this language as PDA, we have considered the string 0 0 1 1. Okay, so we will consider that how we can process this string, means here what is the condition actually. So here number of zeros followed by equal number of ones, such string should be accepted by PDA. That is the main condition actually. Okay, so we have to accept all the strings by the PDA that are starting with all zeros followed by equal number of ones. Okay, so means we have to check first we should have all zeros, and after finishing all zeros we should have equal number of ones. So we have to check this condition and we will draw the PDA for the same condition. Okay, so here I'll take 0 0 1 1 and we have stack with us. Okay, so first we have header at the leftmost position, so at the first 0. So what we can do for this means first we have to match all the zeros with remaining all the ones. Okay, and for that purpose we have stack as a memory. So first I will read this symbol. So in case of PDA we have to perform three steps. That is, first we have to read current input symbol, then we have to perform push or pop or no operation on stack, and then we will move to write by one cell on input tape. Okay, so same is the case. So first I will read this input, then I'll push 0 onto stack. Okay, and then I'll move header to write by one cell. Now my header is at this second 0. Okay, means what, I have finished reading this 0. Okay, so I'll do one thing. I want to check the number of zeros equal to number of ones, and all these ones should appear after the end of all zeros. Okay, so means we don't have any interference of zeros and ones in between the string. Okay, so first I'll do whenever I have all the zeros, all zeros should be pushed onto stack. Okay, and after reading of all zeros, for every one I will pop the 0 from the stack. Okay, so means whenever I'll finish all the ones, then there should not be any 0 remaining in the stack. Okay, so means for every ones I will cancel all the 0 from the stack. Okay, means what, for everyone there is every 0 present, means number of zeros equal to number of ones, and number of ones are appearing after the appearance of or occurrence of all the zeros. Okay, so first I'll push all the zeros onto stack until we have first one to read. Okay, so I have here first 0, so I have pushed onto stack. Again I have second 0, so again I have to push this 0 onto stack. Okay, now next reading symbol is for 1. Okay, so while reading this one, I'll do one thing. I'll pop the stack. Okay, and whenever I read input symbol 1, then there should be a top as 0 and 0 only, because we have to match number of ones equal to number of zeros. We have to check it that number of ones is equal to 0 or not. So if I read input symbol 1, then if there is top as 0 and 0 only, then and then only I have to pop the top. Okay, so that is the must condition for popping. So if I read one input symbol and if my top of stack is 0, then I have to pop the top. Then again I'll move to right by one cell. If again I have 1, then that should be the condition that we have 0 on the stack as a top. Okay, so again I have next one, so again I have to pop the stack. Okay, now next we have blank symbol. So if means what, I have number of ones are over and there must be a condition that we have finished with all zeros on stack also. Okay, so if we compare here, as I have finished all ones, I have finished with all zeros also, means I have finished or cancelled all zeros for all ones as well. Here we can prove that number of zeros are equal to number of ones. Okay, so while reading any symbol from input tape, header have access for the current cell only, means for header this single cell is visible only, means it doesn't remember what is next symbol and what is the symbol he has read previously. Okay, means he has access or he visualize only the current cell only. Okay, he does not remember how many zeros he has read. Okay, so to remember these number of zeros, we have pushed all the zeros on the stack. Okay, so whenever we have number of ones, we would pop these zeros, or we have popped these zeros from the stack, so we can match for every one. There should be every 0. Here we have performed 2 operations, that is push operation and pop operation. So we will list out all the transitions for the given operation. So first condition for this 0 condition was like, we are reading input symbol 0, so suppose we are in state Q and we are reading input symbol 0, so input symbol is A, and while reading this 0, our top of stack was Z0, so this will be represented as Z0. Okay, so we will move to state Q, and after reading this 0, we will push 0 onto stacks. For push operation, we have syntax as OZ0, means this 0 will be pushed onto stack, and before this operation Z0 was the top of the stack. After pushing this 0, Z0, these are the 2 current tops. Okay, now again for the next 0, we will have next condition, that is Q. We are reading 0 input symbol and now current top of stack is 0. Okay, means this is 0 that we have pushed lastly onto stack. So again we have to perform here push operation. So Q 0 0, that will be the transition used to represent. Okay, now next when I want to read 1, okay, so for reading 1, what will be the situation? So we are in state Q and we are reading input symbol 1, and at that time top of the stack is 0. Okay, so here for reading 1, we have to perform pop operation. So if when we have to perform pop operation, we are reading input symbol 1, and if top of the stack is 0 and 0 only, then and then only we have to perform pop operation. Okay, means what, for this one we have to cancel this 0. Okay, so Q comma empty, so this will represent pop operation. Again the situation for this one is same, that is we are reading input symbol 1 and again top of stack is 0, then and then only we have to perform the pop operation. Okay, so there is no need to write this transition again because the same transition will be repeated. Okay, so this was related to push operation. This was related to push operation. Here the top of the stack is different, that's why we have taken two different transitions for the same situation, for the same pop-up push operation. Okay, and lastly we have to add the transition for acceptance through empty stack and acceptance through final state. So we are in state Q and we are reading empty symbol, and if top of stack is Z0 then Q comma Z0. This is for acceptance through final state, and when we want to acceptance PDA, design PDA for acceptance through empty stack, then Q, this Z0 will also get popped out. Okay, so that will be represented as Q comma empty. Okay, so that is for empty stack. Okay, so here we have considered only about this string. Okay,